we have a mechanism that is designed to lift arm weight, right? As you can see, you have a bigger arm here. When you push it up, it's gonna nose down, and it's gonna grab this pulley and push it down. And inside these cables are here. And this cable is going to a set of pulleys, right? It's gonna lift this pulleys up. And you guys see that all these pulleys are massless, frictionless. So at the end, it's gonna bring up this weight, this set of coupled pulleys, right? So this particular structure here is called the truss. So truss is made of rods, not beams. These are rods. So these only accept compression or tension force. They don't accept shear force. So theoretically, if you put a load here, it's going to break. You should have put a load here between you. The loads are only applied here at the joints, not between. So we're not going to talk about the truss today. In fact, we're not interested in the load distribution in this structure. We just use it as a moment arm to lift up this weight. Okay? Now, the question in this problem is, how much force should I apply here such that it keeps this configuration in equilibrium? Find the force F such that this remains in equilibrium. That's the question. So what should I do?
On your system.
Get your system, the first step. All right? In fact, you reach the point that you can easily tell later when you practice a lot. But right now, let's do everything in a systematic way. So the first step is choose your system. So what I'm going to choose is to choose this guy. Let's say this is system 1, system 2, system 3, system 4, system 5, and the entire trash. I choose at my system 6. So these are the systems. Now the next step is the first system. Draw first per system, right? So starting with system 1. Also, let's label this cable. Let's say this is cable 1, and this guy is 2. Cable 1, cable 2. As you can see, cable 2 is like this, right? Cable 1, cable 2. This is cable 3, and this is cable 4. And the cable 4 is the entire thing. So this one that is connected to this structure is cable 4. It's just one cable. You see that? It goes around these 2 pulleys. And we previously proved that if you have frictionless massive pulley and a cable is going around them, as long as the cable is same, the force is the same. Right? We had this, we proved it. So the force is same all over, everywhere in cable 4, and the same in cable 3, and the same in cable 2. But it may be different. But everywhere in cable 4 is same. But when you go to cable 3, the force may be different. So you shouldn't say, well, the force is same all in all cables. So here, this force is equal to this force, because no, there are different cables. One cable is here, one cable is here, and one cable is here, one cable is here, and one cable is connecting this pulley to the same. So we have different cables. Don't forget, the force in one cable is same. When you change the cable, the force may change. All right? So now I want to draw a FED for system 1. What should I do? So system 1, 2, 3. Let's say this is point A. Now I want to draw FVD for this guy, for this mass. What should I do? Every time I want to draw FVD, what should I do? Huh? Walk around to get surface force, and then ask for body force. Right? So let's walk around it. So the only thing you call is this cable. Do I know the force on this cable?
No.
No. So you just put T1, introduce some variable. T1. Unknown parameter. Now you walk around it, and that's all. This is the only interaction that this isolated system can have with the surrounding. That's the only way it can communicate to the surrounding through this cable, right? Now let's go to body force. We're done with the surface force. Let's go to body force. Do I have body force?
Yes.
So it's going to be mg. So that body force is 20 mass times 981. So I'm done with FVD for this guy. Now let's go to this bullet. Walk around the surface. So you get T2 here, and then you get another T2 here, and then you get T1. Now you go to this guy, you get T3, you get T3, you get T2. Now you go to this guy, you get T4, you get T4, you get T3, and this guy, you get T4, T4, and T5. Let's say this is cable 1, 2, 3, 4, 5. This one, this cable that is connecting this pulley to the sail is tail number 5. So that's T5. So this guy becomes T4, AX, AY, and F. That's my FVD for all systems. As you can see, for system 2, all I did, I walked around it and I cut this cable, and this cable. But look, these two cables are just one cable. So you have one unknown parameter. Let's call it T2 because this is cable number 2. So I say T sub 2. But this one, this force, you see this cable is connected to the center of the pulley. So the force number of center is just T1 coming down. Now you do the same, you go to this system. Then you have 3, 2. You see that? Now you go to this system, you have 4, 3. Now you go to this system, you have 5, 4, 4. And finally, you come to this final system, this guy. 2 steps. Walk around and get surface force, then body force. Now if you walk around here, the first thing you cut is the force in that cable. And we designate it by T4. So I just use this value, but just flip the sign. Because it's the same according to Newton's third law of action and reaction. Right? T4, you walk around and the next thing you cut from the surrounding is F. Because somebody is like pushing it, right? So if I want to isolate this, you have to put this effect coming from the outside world. Somebody is pushing it. Here, AX, AY is a pin connection. I don't have a moment. Why I don't have a moment at A? I don't have an unknown moment like MA. Why? Huh?
Because there isn't one, it's not offered,
Huh? Say it again.
it's not given.
Well, this is a pin, right? This can easily rotate around point A. So no, there is no resisting moment. There is no like let's assume that this was welded here. If this was welded here, you would have unknown moment too. So in addition to AX, AY, two components, you would have unknown M if that was welded to that point. But right now, it's just a frictionless pin, so you can easily rotate it. So nothing is resisting you. There is nothing, zero. right? Every time you draw free body diagram, you say, can I move it in X? Like only this point, just forget about everything. Can I move it in X? No. So there is something resisting and you don't know it. It's a reaction. That's what we're trying to find. Now say, can I move it in Y? Can you move it this guy in Y direction? No, it's pinned here, right? So there is a reaction, AY. That's unknown. Now you say, can I move it? Like, can I rotate it like this? Can I rotate it about this point? Yeah. You don't need to put so much force in it to do that. You can easily rotate it on it. So there is no counter moment coming from the reaction there. This is the 2 pages I said, study the free body diagram 160 and 161. One of those 2 pages. This means that this comes from that. The way you isolate the system. Alright, so that's my surface force and then body force. Well, this is massless, frictionless. It has nothing to do with friction. It's massless, so body force is 0. Now, this is my FED. Now what's the next step?
Equation.
Equations, and then solve, and then verify. So we know that. Well, let's do it faster than this, because it's just, this problem is so easy. It's just everything is obvious. So if I write equation for this system, how many equations do I have per system? 3, because it's a 2-dimensional problem. Every time I have 3 equations per system. First of all, can I solve this problem or not? Before I even start writing the equation, can I solve it or not?
Yes.
Yes.
Why?
Because you have 3 equations, lessons for each system and 3 problems for each one.
No, hold on. Before you answer it, the total, how many total unknowns do I have? How many unknowns do I have in this problem in total?
6, 7, 8.
8.
8, right? 1, 2, 3, 4, 5,
6, 7,
6, 7, 8. 8 unknown, right? How many systems do I have?
8, 6, 8, 12.
5, 6. 6 systems. Each system has 3 equations. So 18, many equations. But don't forget that we have a lot of non-equations. Summation of force in X. So the number of equations is greater than the number of unknowns. So yes, I can solve it. So that's the motivation to go to the next step. If it turns out that you don't have enough equation, because I may give a question at the exam, that you don't have enough equation, and then you see there are some students trying to solve it, and they don't even consider all the questions in the exam. They just work on one question. And they write 3 pages, and then the answer to that question is just 1 line. Indeterminate, I can't solve it. And they have 3 pages and all wrong. And they didn't have enough time to do other questions, so they failed. So try to not to do that. Just make sure that you count the number of known and unknowns and equations, and you can solve it. If you can't solve it, then you go to the next step. Otherwise, you just say indeterminate. I cannot determine all unknowns here. But it seems, here in this case, it seems that we have enough equations, right? So now we'll go and solve. Here, summation of force in X, 0. What kind of equation is that?
No.
It's a null. 0 is equal to 0. I don't even bother. Summation of force in Y, 0. What do I get? If I write that equation, summation of force in, huh?
In the X direction or the Y direction?
In Y direction. If I write summation of force in
Oh,
Y.
it's T1.
T1 is equal to this guy.
Yeah,
20 times
9.8.
9.8. So here we can write 20 times. Although we know that, don't forget that. We should write all the equations and then we come back and solve it. But this problem is so simple that you can just, everything is decoupled. You can start from 1 point and solve all the way down. Right? So this is 20 times 9.81. Do I need to write a moment equation? Now, if you take this point as your reference point, what type of equation is a moment equation?
No.
It's a null equation. 0 is equal to 0, right? Now let's go to this system. If you do the same thing, summation of force in y0, what do I get? T2 plus T2, so you get 2 T2 is equal to T1. That means T2 is equal to half of T1, half of this value, which is half of 20, 10 times 9, it's going to be 98.1. You see that? Now, what about summation of force in X? No, don't write it. Summation of moment about this center is a null again. That would give you, if you assume that this is T2 and T2 prime, assume that these are not equal, that would, summation of moment on this point would give you T2 is equal to T2 prime. But since we know it already, then summation of moment on this equation gives you 0. The right hand side is 0, so 0 is equal to 0, it's a null. So don't even write it. Now next system. What do I get for T3? 2T3 is equal to T2. So T3 is half of, so it's going to be 98.1 divided by 2. Now if you go to this guy, what about T4? T4 is equal to T3 divided by 2. And T3 is this, so that's going to be 98.1 divided by 4. Because this is already 2, divided by 2, divided by 4. Right? So I have this guy, so I can immediately get my T5. T5 is equal to 2 T4, which is equal to 98.1 divided by 2. Now let's go to this guy, the last system. So T4 is equal to 98.1 divided by 4. Now, if I want to find F, let's say the question to this the question was find the value of force such that it keeps the system in equilibrium. Then what should I do? Do I bother to find AX, AY? No. I just write the moment around A to get rid of this 0. You see that? The choice of moment equation can do magic for you. In fact, you can make a lot of coupled systems decoupled by just changing the moment equation. It's kind of a try and error. You change the moment equation, write the equation, and you see they become decoupled. So moment around A, 0. What do I get? T4 times this distance. What is this distance from here to here? 2. So 98.1 divided by 4. This is T4 times 2 from here to here. Positive or negative? Negative. Right? Moment coming from here is 0. Moment coming from here is 0. They go all through the 28. Plus moment coming from force F with respect to A is equal to what? Moment of this force with respect to A.
4F.
4F plus 4F. What else? That's it, right? Is equal to 0. So F is equal to half of 98.1 divided by 4. So it's equal to 98.1 divided by 8. So that's the way you analyze your system, by doing 5 steps. Now, how do you verify it? Let's say you get a bunch of numbers here and I don't know if I did it right or wrong. Right? How do you verify it? Huh? Any idea? How do we verify it? Let's say I get this data, and then I want to see if my answer is right.
You could back substitute, and then if you get 20 times 9.81 at the end, it'd be right.
Mhm. Yeah, you can do that. Or also, you can say, well, the cables. Look at the cables. What particular property do we have at cables? The tension. It should be always tension. We don't have compression at cables. So if I choose the direction this way positive, and I solve it, the final answer should be positive. It should be negative. Negative means compression. If this sign is positive, negative means compression. So all my cable forces are positive. So probably I'm doing right. Again, this is when you verify it, the last step is not 100% verified. We don't have 100% verification in engineering. When you have 100% verification, when you actually build it and test it and measure it, that's the final proof, the measurement. And you say, well, you know what, I computed this force, and then my final measurement is very close. Usually it never becomes exactly the same. It's close. So my system is verified. But look, we don't build this in the final exam or midterm. We can't build this. We don't have enough time to build it and test it, all right? So how can I verify it? By just checking something like force in a cable should be positive. There is no way that they can get negative. So if you get a negative here, you just say, well, something is wrong. Let's go back. Let's check it one more time. And also, another thing, this is supposed to be a lifting mechanism. So what's the purpose of lifting mechanism? The purpose is with applying a little force, you should be able to lift heavy things. That's the purpose. Now look at the final answer. My final answer is 1/8 of the weight of this guy. This 98.1 is the weight of this mass. So the force is required to lift it up is 1/8 of 98.1. So, well, this makes sense because this is supposed to be a lifting mechanism. Now it makes sense, right? Okay. So this is the way you may have problems like that in the exam. I may not tell you to solve everything, right? Just please read the question. If the question is forcing this member, in fact, you could solve it with one moment run A. You don't need to write summation of force here is 0 to find AX. You don't need to find AY. How can you find AY? If I ask you to find AY, how can you find AY?
Take the moment on that.
Yes, that's one way. Another way, summation of force in y direction, 0. Right? You already have this. You already got this guy plus AY is 0. And then AY is just this plus this with a negative sign. You see that? So what I'm trying to say, always read the question. Because sometimes you may have just 1 or 2 lines and you can just get rid of that problem, go to the next one. You know, this makes you a good engineer. A good engineer wants to escape many extra unnecessary computations. He wants to just find the shortcut, although he can do everything that you can imagine, all computations, but he does not want to waste his time because the problem size is a very small engineering problem. When the problem size gets bigger and bigger, you won't have enough time to do all these particular things, right? Okay, now let's go to another problem. In fact, I'm trying to prepare you for problem, I want you to add something to it because this, the thing that your book is asking for is different from what I want to ask for. I say find reaction at point A. Let's say this is a question. Find reaction at point A. I'm gonna find it. Let's say I give this in the main printer number 2, and then it say find the reaction at point A. How do you start it? Can you solve it?
Break it up.
Break it up. Break it up into systems. How many systems should I take?
2.
2. Right? And then after you choose system, then what do you do?
Free body diagrams.
Free body diagram. And then what?
Equations.
And then solve it. So if I see that you're doing the steps correctly in order and things are matching, you know, you get some credit. But I don't want to see some numerics like immediately. Like Bx is equal to 12 times 16 times blah, 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 blah. I don't want to see that. I want to see a correct thought process. So if I break it up, I get this part and this part. Right, so this is my first system. Let's say this is my sys1, and this guy is system 2. Right? So when you break it up, you have 2 systems, and then you start drawing FED. What should I do in order to draw FED for this guy? 2-step procedure. Walk to get surface force. Step 2, add body force. Let's say these beams are massless. And let's start walking from here. So the first thing I caught is the connection between this beam and wall. And let's say this beam is welded to the wall. Okay? So how many unknowns do I have at A? How many reactions do I have at A? 3. Right? So you ask this question. Can I move it in X? No. So there is a force that keeps it from moving in X. AX. Can I move it in Y? No. There is a force that prevents it from moving in Y. Can I rotate it freely about A? No. It's welded, right? So there is a counter reaction moment at A. So you're going to have AX, AY, and MA. The sign is not that important, like pick some orientation and then just put it in the equation, then you get the right answer. Doesn't matter what sign you pick. If the actual sign is this, you get positive in your final answer. If the actual sign is the other way, you get the same final answer but negative sign. Okay, so don't worry about that. Then continue walking, then you cut this 200 force. What should I do? Replace it with point load. So the point load is 200 times 6 divided by 2, and it's going through the center.
Why is it divided by 2?
The area of triangle. So it's,
Half.
in fact, you can do that. You can break it up into 2. This is another option. You can break it up into 2 triangles. So that's this one is half of pi 200 times this space, which is 6 divided by 2, 3, plus this one again is half of 200 times 3. Now factor out half of 200, so you get half of 200 times 3 plus 3, 6. That's what I have here. 300 times 6 divided by 2. You can do that. Do whatever you like to do. And it goes at the center. Alternatively, you can put it 1/3 of this side, 1/3 of this side. This side you could have 2-point force, but the end result is same. If you put it at the center, it's same. Why did I put it at the center? Because it's symmetric. It's just the geometric center is at the very center. Now continue walking, and then you cut this pin here. How many force and moment do I have at this point B?
2.
2 forces, right? Bx, By. Bx, By. Do I have a moment at B?
No.
No. Again, that question, can I rotate it about B? The answer is yes. Look, in the test, I don't want you to guys put a moment there. If I see a moment 0, then I immediately just look it up. I don't even grade it. This is the most terrible mistake. That means that you didn't study even the basics of intuitions, like frictionless pin. Well, I don't have a moment there, and nothing comes from the outside force. Nothing is resisting me. You can easily rotate, right? So Bx, By, and continue walking, going back to the point. So I'm done with the surface force. What about body force?
No.
No body force. This is massless. Massless beam. Very light beam. That's a composite. Made of composite material, right? So I'm done with this guy. Now let's go to system 2. Again, walk on the surface, put the external load on it, and then you go to body force. First surface force. And starting from this point, what should I put here?
Bx, By.
Yeah, the same thing, but different sign. Bx, By. See that? And then here you have 800 right here. From here, what about point C? Yeah. How many force and moment at C?
Just 1.
Just one in Y, right? You can easily move it in X. So 1 CY. And that's it. That's my FPD. Now next step. What is next step? Write
Equation.
equations. Before we write the equation, what do we do?
Figure out.
Feasibility study. Can I solve it or not? Right? How many unknowns do I have? Or total unknowns?
6.
6 unknowns. How many equations? 6. So 6 equations, 6 unknowns. Can I solve it?
Yes.
Yes. Right? Now let's go to solve equation. So in this system, this is system 1. And this is system. Let's just write the equation right here. Summation of force in x0, dx plus ax is equal to 0. Summation of force in y, dy minus 600, and that's going to be 600. So by minus 600 plus ay is equal to 0, and summation of moment on this point is 0. So what I want you to tell me what I should write here. Summation of moment around point A. Let's start with AX. Does it have any contribution to the moment? No, right? AY.
No.
What about this guy?
Yes.
MA. Do I know it?
No.
No, so just add MA. Positive or negative? Positive. So MA. Now go to the next one. Moment come from here with respect to A. What is it? The value of force times 600 times
Distance.
distance, and the distance is
3.
yeah. So 600 times 3. Positive or negative?
Negative.
Negative. What else? EX. What about BX?
No.
What about BY?
Yes.
Yes. Plus BY times
6.
the entire thing. 6. Right? So this was 3, this was 6. Is equal to
0.
0. Look, don't go to the system 2. This is system 2. Another fatal mistake that you make, if you write moment come from this guy, this means that you didn't understand what the FED is, what the system is, what the isolation is. Right now we isolated this guy from the surrounding. So we don't see system 2. When I work on system 1, I only see this guy. Okay? Now let's go, this is system 1. And go system 2. Summation of force in X is equal to 0. What do I get? Negative dx is equal to 0. Summation of force in Y, Cy, negative 800, negative dy is 0. And summation of moment around any point should be equal to 0. I would take Cy on C. Summation of moment around C should be 0. So then I get dy times this length, which is 4. What to do again?
Why should take it around C and not B?
Yeah, I'll take it around C.
Why?
Well,
Don't B have more unknowns?
It's the
No?
same thing.
no, I'm trying, you can do that, it's the same thing. As a matter of fact, when you write your equations, you can also come back and play with it. Change the moments, reference moment. Sometimes you have to do that. You have to change the reference moment to decouple your equation. Sometimes your equation become coupled, tightly coupled, so you have to play with that. But here, I'm trying to find the information for by. Look, if I take by is going to vanish, and I already have a by here, you see? So because I took my moment about this point. So by show up. Now, I don't want to get rid of by. I want to have a equation to by to vanish, to show up, so I can put in information here and solve the other one. So that's kind of like the answer to that question is, you need some, when you practice, then you get it, what point you choose. It's kind of like, it needs some experience to pick the point. So by times 4, positive or negative? Positive or negative?
Positive.
Positive. Then you go to bx.
0.
0. This guy
800 times 2.
plus 800 times 2. This guy is already 0, going to that point. Is equal to
0.
0. So let me label them. Now we go to the solve step. So we wrote all the equations, now solve. So let's some tables on it. 2, 3, 4, 5, 6. Which one should I start to solve first? 4. 4. So bx is 0. This is just the most stupid, easiest equation you can ever get. So bx is 0. Then what's my next step?
1.
I can do 6 too. Or I can do 1. Or, yeah, just 6 or 1. 2 possibilities. So let's do 1. Then ax is equal to, that would give me ax is equal to negative bx, which is 0. And then I solve this guy. by is equal to what? I solve 6, equation number 6, and then by is equal to negative 400. Right? What else?
5.
5. Cy is 800 plus by. Negative 400 is positive 400 Newton. Now, can I solve this guy?
Yes.
Yes. And it's going to be MA is equal to 1800 negative 6 times by negative 400. So that's going to be 1800 plus 2400. So that's NA. What about this guy? Yes. AY, we solve this guy. AY becomes 600 minus EY. EY is negative 400, so it's going to be plus 400. So it's going to be 1,000 Newton. That's it. So we found all the reactions. And you see, interestingly, the moment here is not zero. You have a bending moment at what? They call it bending moment. It's a moment that at that point that you weld it, it prevents the system from rotating over that point. So when you apply this loading, this pin is going to deflect like this. This pin is going to deflect like that. Like that, you see? The slope is zero here because you have a moment that is preventing from rotation, right? So this is like this and then goes on down. The slope is zero because they really at the wall. If you had a pin, then this would go like this. Because you can easily rotate over that point. See that? So verify the last step. Now we solved it, we got all the answers, and then the last step is you have to verify. Is there any way, sometimes there is no way that we can verify it? Either the geometry is complicated, or the physics, or the problem is complicated. So is there any way that I can verify in this problem? When I say verify, I'm talking about something that shows you that you have done terribly wrong. If it's terribly wrong, then you just go back to step one, choose system. If you just check, see if you have done everything correctly. Do you see anything terribly wrong here? Well, just look at the C. The actual reaction at C should be upward, positive. If you get front lancer is pulling this way, then you're doing right. So let's go to CY. CY positive. You see? BY, I'm not talking about BY, but I'm talking about CY. So CY, this force that I choose in direction here, whatever answer I get should be positive. Should be actually guarantee this sign. Although I don't know if positive 400 is right or not. Maybe it's 450. Maybe it's, well, I don't know. Maybe I've done something wrong in the computation. But at least I know it's not negative 400. If it's negative 400, then you say, how come this force is negative? That means that I have to have, this roller need to have applied negative force in order to keep this in equilibrium. Is that physical? No. So I'm doing something wrong. But right now, it doesn't look that it's terribly wrong. So when I say verify, because we don't have solution manual in the exam, or when you work in a company, there is no solution manual. Everything is a brand new design, right? It's something that you come up with it just for the first time. You're just doing it yourself, right? So there is no solution manual. So how can I verify it? Well, simply search for something that is terribly wrong, like a negative CY. Search for things like that. You will find there are other things. There are other things. There are other things that you realize, oh, that's really terribly wrong. So okay, let's close this class, and Wednesday we're gonna either have one or two questions. I'm not sure about